All right, folks, so now we're looking at absolute value equations. This is example number 1 that we're about to look at here. And just for the sake of clarity, this will correspond to assignment number 13. So again, I hope that these examples would be of use to you. So this is definitely an absolute value equation because, again, it's got these absolute value bars here. That seems like a pretty easy recognition. Absolute value bars, by the way, do not behave like parentheses in terms of distributing. So actually, if you're tempted to distribute the 2 into that, I have to tell you that's not what we need to do. So this is going to vary a little bit here. Again, if you look at the notes that were uploaded, the PowerPoint slides, you will find this particular slide already filled in. So we're going to talk about isolating the absolute value. We want to get that absolute value expression by itself on one side of the equation. So, just like any other discussion of isolating, whereby we use the order of operations to do that, parentheses, exponents, multiply, divide, add, subtract, that's how you isolate an entity. So, anyway, if you looked at this, wouldn't the further operation here be the subtraction? So we should first of all add that 6 over to the other side. See, that's the furthest operation from the absolute value. So, the equation transforms now into this once we add the 6 over. Again, we want to isolate that absolute value expression. What's going on? That 2, what's it doing to the absolute value? It's multiplying. So, wouldn't we get rid of that 2 with division? And therefore, we'll divide both sides of the equation by 2 at this point. So, let's pull this up here and see what it looks like at this point. We now have the absolute value expression all by itself, and it equals 7. Okay, so we have successfully isolated that absolute value. The next general idea, as you see in your notes, would be that we want to split this up into 2 separate equations. All right? And I'm going over this faster than I would in class, but you already have the pre-filled notes, so you just pull those out and look at them as I discuss it, all right? I'm a visual person, as you well know, so I like to draw a number line here to understand this. I want to remind you that when you apply an absolute value to something, you're talking about the distance from 0, all right? So the point would be this: if that expression is going to have an absolute value of 7, that means that expression could be 7 units away from 0. And there's 2 directions we could travel. So, for example, if we traveled 7 units this way to the left of 0, wouldn't we land on -7? And so, if we were to set that expression equal to -7, that would be a potential solution. Because if you think about it, any number that makes this thing -7, if that thing inside there equaled -7, and we took the absolute value of it, it would equal 7. So this will work. That'll be one equation. The other would be if we were to take that expression and travel 7 units in the positive direction from 0. And so the other equation that we'll split off here is 4x plus 5 equals 7. So again, the one-word description split, we split this into 2 equations. We set that equal to -7, and we set it equal to +7. Notice we left the expression alone. All right, so we didn't change it to 4x plus 5, 4x minus 5, for example. We brought it down in its entirety and set it equal to those 2 different numbers. And then at this point, it's flashback because we should be able to solve whatever's left standing. There'll be 2 equations after we do the split, and they're probably going to be either linear or quadratic. These are both linear, so again, the idea would be to solve them on out. And so, for example, on this one, we would subtract the 5 over, right? Got to keep them separated. And then we'd get rid of the 4 with division. Divide, divide, all right? And that is -3. Okay, same thing over here. That's a variable, that's a constant. You got to keep them separated. Assignment 8. We covered that before spring break. And again, I wish I had somebody over there doing all the links for me. And then you get rid of that, multiply with divide, divide. And again, 2 divided by 4 reduces to 1/2. You could call it 0.5. I don't care. And so again, looking at those 2 answers, if we could please put them together in a solution set, just to make it easier for the paper grader to find them, and everybody's happy. All right? So that would be example number 1. We'll see you in a few.